Good morning, wherever you are, and welcome to another session of digital forensics. As I noted on Discord, which you all should be on Discord already, Google hasn't given me the codes yet, and I looked at the sheet. They haven't updated it. So we're still hanging around, still hanging and waiting. But it should be hopefully soon, so that we can get that out and start building stuff. Any questions from last week before we get rolling into this week? Looking at the Discord chat. Yes, I'm streaming on YouTube. I see nothing in Zoom. Nothing on YouTube. Okay. Today's lecture covers some OS stuff and then spends a good amount of time in Windows. Mostly because we find Windows everywhere we go, as annoying as it is, as broken as it is, we find it everywhere. So we kind of have to have a good understanding on how to look at it from a digital forensics perspective. So yay, so much fun. To begin with, we have to have a strong foundation of operating systems in understanding how they save data, because that's what we're working with. We're working with saved data. Their primary evidence that you'll be working with is files. Knowing how operating systems organize those files, the data they contain and their locations will vary according to operating systems and associated file systems. And as a refresher, a file system is a hierarchy of files in their respective directories. Because the way that APFS in Apple saves data is different from the way NTFS does in Windows, is different from the way that X4 does in Linux, among all the other formats that exist. So again, we're going to focus mostly on Microsoft. An investigator should understand, regardless of the OS, an investigator should understand allocated storage space, which is an area on a volume where files are stored, the unallocated file space, the free space for data to be written, and a partition, the logical storage unit on a disk. At the very bottom, we have bits organized into 8 to form a byte, and that is the smallest addressable unit in memory. A sector on a magnetic disk represents 512 bytes. On an optical disk, a sector is 2048 bytes. Newer disks have sector sizes of 4096 bytes. A bad sector is an area of a disk that can no longer be used to store data, which can be caused by a piece of malware, a corrupted boot record, a physical disruption, among many other reasons. A cluster, shown here in green, is a logical storage unit on a disk that contains contiguous sectors. When a disk is partitioned, the number of sectors in a cluster is defined. Clusters can have 1 or 128 sectors. Tracks, shown in blue, are thin concentric bands on a disk that store sectors where data is stored. Because most files are comprised of 512 byte blocks, it's important to understand that an 800 byte file would use 2 sectors and have file slack or unused bytes in the last sector of a file. In this example of a file having 800 bytes, the physical size of a file is 1024 bytes or 2 sectors. The logical size is 800. Does that make sense? Cool. Investigators like yourselves will spend time examining hard disks. A platter is a circular disk made of aluminum, ceramic, or glass that stores data magnetically. A spindle at the center of a disk is powered by a motor that's used to spin the platters, allowing actuator arms that have read-write heads to modify the magnetization of the disk when writing. They typically have 2 heads for each platter since data is written on both sides. Since these heads are nanometers from the platter, they must be handled very carefully and prevent any magnetic device like a cell phone, a microwave, a magnetic screwdriver near those platters. A cylinder is the same track number on each platter, spanning all platters on a drive. Disk geometry refers to the structure of a hard disk in terms of platter, track, and sectors. The way that it's all calculated is the number of cylinders times the number of heads times the number of sectors times the number of bytes in each sector. Virtual memory is a feature of most operating systems. The page file, that's what it's called in Windows, is an area on a hard disk that stores an image of RAM. Pagefile.sys stores frames of data that have been swapped from RAM to the hard disk in order to allow running applications enough room to utilize RAM if it runs low on space. RAM, pagefile.sys, or any virtual memory is invaluable to investigators since it contains information about running processes, passwords, and web browsing artifacts. Being able to get information off of the page file will yield quite the wealth of information. Investigators need to be able to convert between different numbering formats. Oh, I see what happened. You need to be able to convert between different number of formats in order to see different ways that data is displayed. Some files on a computer are in binary format and will need to get converted. If you haven't had an understanding of hexadecimal to ASCII, there is a table in the notes that you can use. File headers are all in hex and allow you to identify files even when a suspect changes the extension to hide data. Because that's a very low-level trick of, here's a picture file, let me change from JPG to whatever else, to a Word document. The extension doesn't necessarily dictate what the file is. The data is still the data. If it's a picture, it's still a picture. Just because you change the extension doesn't automatically change the data itself. So being able to look at the hex value you'll be able to identify, oh, this is a picture, irregardless of what it has an extension, or if it doesn't have an extension. Still looking at the hex values, we'll be able to determine what it is. Jumping forward into the boot process, the kernel is at the core of an operating system and is responsible for communications between software and hardware. When a computer is powered on, the computer executes the code stored in RAM, referred to by the BIOS or the UEFI, which initializes all the system devices. Bootstrapping is the process of running a small piece of code to activate other parts of the OS. In many examinations, the hard drive is already removed to be imaged or cloned, especially in this class where we're not actually going to deal with physical hardware. If it was in-person and we were dealing with physical systems, you would also have to document all the details about that system and the specifications. The master boot record. It is the first sector on a hard disk, sector number 0. It's involved in the boot process and stores information about partitions on a disk, including how many exist and their locations. The MBR is comprised of the master partition table, the master boot code, the disk signature, and the end of sector marker. Windows, now getting into the Microsoft of things, supports 5 main file systems: FAT12, 16, 32, 64, and NTFS. FAT stands for the file allocation table, using, as the name implies, a table to store information about where files are stored, file space available, and where files cannot be stored. NTFS, or New Technology File System, replaced FAT back in '93 and is still being used. FAT12 you would find in super old floppy disks. It's universally supported by modern OSs. FAT16 was a 16-bit file system for MS-DOS with file name limits to 8 characters, file extensions to 3 characters, and disk partition maximum of 2 gigabytes. FAT32 was a 32-bit version, and grew a maximum file size to 4 gigs. FAT64 is also known as exFAT. It can be recognized by Mac OS, but all like the predecessors, none of them contain the process of security or journaling. And journaling is the file system record keeping made to a journal. NTFS brought in file compression, 16-bit Unicode for international appeal, access control lists to enable permissions associated with files and folders, and also journaling. The journaling file in NTFS is $log file. NTFS also maintains a unique sequence number that will record the following: things like the name of a time of change, reason for change, the file or directory name, any attributes, the master file table record number, the file record number of the file's parent directory, the security ID of the user, the update sequence number for the record, and information about the source of the change. These are important when dealing with a case, because if the criminal is trying to hide what they did, we can look at things like the journal and grab this information and be able to show that yes, indeed, they had X, Y file. Yes, they interacted with this program. You can't hide what you did. There is in NTFS the alternative data streams. A file set of attributes allowing files to have multiple data streams that can be viewed only by accessing the master file table. For example, when File Explorer shows you details about a music's file logical path in the file system, VLC might use an additional data stream to update album information or associate the music file with other music from the same artist. So there's more than one way to access that data. And of course, malicious actors will use that to get to information or add information that wasn't there before. The wonderful master file table maintains file and folder metadata, including the file name, the creation date, the location, the size, the permissions, compression, encryption, deletion, and free space to be reallocated for every file and folder. Again, just because you delete something doesn't mean it's completely gone. There is a record of it on that drive. The default size for each entry is 1024 bytes. The MFT header accounts for 42 bytes and the remaining for attributes. That could be resident, that's content stored in MFT, or non-resident, stored in other clusters. Timestamps in the metadata or the master file table can be manipulated. It's always advised to compare two master file table timestamps. Use the standard information and the file name attribute. While the standard information can be manipulated, the file name attribute one cannot. This table shows you where different information is stored. So in the master file table, at the beginning is the MFT itself, containing the file record. MFT mirror is the duplicate. Next to that would be the log file, that's tracking the metadata changes, information about the volume, and so on. So within the master file table, you have at minimum 12 different positions, 12 different files, if you will, and the file name for each of these that sit in the master file table and what they are. Crazy the amount of information that is that NTFS keeps. Prefetch, which are files that end in .pf, increases an application's performance. They contain information like when it was created, the number of times it was executed, and any files or folders associated with the executable. These files contain timestamps like the last run and volume creation time. From Windows 8 forward, Prefetch has 8 timestamps according to the last run times. Again, useful information for an investigation. How many times was a program accessed? How many times did the perpetrator look at pictures because they ran the pictures executable? We can find all that out. Prefetch files are stored in the root directory in the Windows folder, Prefetch. The registry, which we'll talk about in a bit, I have the location in the notes of where the Prefetch data is stored. There's also the Superfetch files introduced in Vista that works with Memory Manager Service to increase performance. Superfetch data is collected by the service host, which is the actual file is svchost.exe. And that is located in the root directory system32 sysmain.dll. Files are stored in the prefetch directory with prefix AG and extension database, or DB. Those are the superfetch. Shell bags provide user viewing preferences for File Explorer. We can see a user's sizing and positioning of a folder window, tracked when folders were viewed by a user, and so on. And this data lives in Registry. And again, the location of that is in the notes. Simcache contains a record of executed binaries, which have been viewed in Explorer, but not executed. In XP, there was a maximum of 96 entries kept. In Windows 7, the maximum was raised to 1,024. File metadata stored can include the full file path, the file size, the process execution flag, the last update time, and last modified. Isn't this awesome? All the different places that you can get information. Now, this piece of work is the registry. This is the underbelly, the soft underbelly of Windows. The registry is the hierarchical database that stores system configuration files. It maintains files used to control the operating system hardware, software, and keep track of users. In terms of evidence, Registry can provide internet searches, sites visited, passwords, user activity, and everything else we mentioned so far. As always, a word of caution. I mentioned this is the soft underbelly of Windows. Changes to the registry may cause serious problems to Windows. Entering the wrong information, modifying it in a way that you weren't quite too sure might render Windows useless. Hooray. The 5 major hives are the class's root, contains file name extensions like executable, like PNG, and so on. So every file extension that it's ever seen gets stored there. Also, here are any COM objects, Visual Basic Programs, and other automation. The Component Object Model, or COM, allows non-programmers to write scripts for managing Windows OSs. The current user contains user profile for the current profile that is logged into the system when it's viewed. This hive changes each time a user logs into the system. Within this profile, we have things like the desktop settings, network connections, any printers, personal groups. This hive itself contains very little data, but it's really a pointer to users. Local machine contains information about the system settings, including information about the computer hardware and operating system. The users has information about all registered users on the system. Within this hive are a minimum of 3 keys. The first is default, which contains a profile when no users are logged in. There's also a key containing the SID for the current local user, which always starts with something like S1518, then whatever. There's also a key for the current user with underscore classes at the end. HKey current config contains information pertaining to the system's hardware that is necessary during the startup process. Within this hive are things like screen settings, screen resolution, and fonts. Information about plug-and-play BIOS is also found within that hive. This last section contains different information about Windows features that have been added throughout the years, things that become important to us as we get our minds into investigations. So for example, in Windows Vista, automatic defragmentation was a thing. That's important to us because defragmentation moves data from one place to another on a drive. And we need to know that. Ready Boost became a thing with Vista. So any data stored on a USB drive would be encrypted with AES 128. So ideally, you want to capture when the system is on and logged in, because it would be unlocked. The volume shadow copy service. There's two types of shadow copy. There's a complete or a clone of the volume, and copies only the changes to the volume. They're shared in the original volume and the shadow copy volume. We can get information from that. Vista has hibernation, and that file is hyberfill.sys, which contains all the contents of RAM during hibernation. Again, a perfect file to grab everything that was in RAM. Windows 7 brought in biometrics. Biometrics can be used to link a suspect to a series of events. Windows 7 uses the Windows Biometric Framework. In the realm of Windows 7, we have the jump list, a taskbar feature that allows the user to quickly access recently used files or actions. So again, we can see what they recently did and show that the suspect was accessing said file or suspicious files or whatever. The Backup and Restore Center is a native tool that provides file and image backups and can utilize NTFS hard drive volumes. Restoration points can be done on the registry, on files, and others. So again, useful to us. Certain versions can also upload backups to network locations. And that's important because that could impact the scope of a search warrant. BitLocker to Go became a thing, which would encrypt USB drives with AES. There is a tool called Coffee, the Computer Online Forensics Evidence Extractor. It's a law enforcement tool developed by Microsoft to work with systems that have BitLocker on. So yes, that does mean that the government does have a way to get around BitLocker. For those of you on Windows systems who thought enabling BitLocker made you safe, haha, haha, haha. Establishing ownership of a USB device. Most USB devices leave a timestamp and other metadata in registry, such as a serial number or an IID code, which can be used to find out when it was last attached to a suspect system. Another tool called USB Review can bring up that information. Touchscreen was brought in Windows 7. So keyloggers are not necessarily an end-all solution. You will need now, from Windows 7 forward, to dust for fingerprints to find corroborating evidence to prove ownership of the computer system. Oh, thank you for the laugh. There are sticky notes that could contain important information saved by a suspect. Event Viewer, never rule out logs. They always have wonderful information. There's the web browser, who may or may not save data to disk. And file grouping. files being placed together regardless of where they are on the disk. Allows for faster searching for both the suspect and the investigator. Looking at the index, when Windows asks, hey, do you want to index the drive? That is also useful. That information is stored in Registry. (8.1) brought in picture password, allowing users to select the photo with a series of gestures to unlock the computer. In 8.1, deleted files are found in the $recycle.bin folder. Windows 10 gave us things like notifications. Messages are retrievable from the volume users within the username, within the folder of the user, app data, local, Microsoft Windows notifications, appd.dat. So just because you took away that notification does not mean it's completely gone. So let's say an email came in for a suspect containing the information that law enforcement is looking for. And there was a little pop-up when that email arrived. And it has enough information that we can corroborate that this email did hit this person regarding this case. There's the proof. Microsoft Edge, their browser, has a location where web browsing artifacts are stored. Cortana also has search history that can be found within the drive. And this is just a small sample of all the places that you can get information from Windows. Any questions? Or did you just get spooked? And a lot of fun stuff. Oh yeah, and once you really get into things like autopsy, but like 1 or 2 weeks, you'll actually play with various file formats and data and just see how much data is stored and how much it's kept. So this week, we have 2 things. We have the binary games and a Windows investigation. I will note, so I have a link here to binary games for you to play. You'll get through these. Save the answers. Do not jump into this quiz when you have the first. Do them all, 101, 102, 3, 4, 5, 6, 7. Then when you have all of them, then go here and start the quiz. This is how I'll know if you paid attention or not. Secondly, if you have a Windows machine or a VM, play with it for a while, especially on a VM if you haven't played with it, and look at the information that we talked about. Now, if you're on a Windows machine already that you use as your daily driver, take a peek at the stuff that we talked about. see what information is being stored for yourself. Now, I don't need to know all the little details, but it's really more of a reflection on the amount of data being stored. So I'm not asking for a 20-page paper. I'm not asking for details on what you do on your machine. I'm just asking for your reaction as you looked through the various places that we talked about and you saw your data there. What did you see? Like what did you see a lot of yourself? Is it not saving as much? You know, again, I'm not asking for an essay and I'm not asking you to divulge all the contents of what you do with your machine. But it's really more a reflection of a understanding of these are the various places that you get valuable information from. Because as we get into cases, this is where that will come into play of remembering where things are stored and how you can get that information out. There are no updates about GCP, still waiting on Google. Is there a way to submit our success completion of binary games or just training for the quiz? Play the binary games, put the answers that you get on a text file or something. When you have all 7, then do the quiz, which is really just a copy paste. Not even gonna lie. Where is it? Preview. That's what the quiz looks like. So do all 7. When you have all 7, then go in here and copy paste. That's what I'm saying. Don't do the first one and then try to do this, because you'll see all the other ones and go, uh-oh. Can't tell you how many times students don't listen to this and then freak out and then ask for a retry, when all you got to do is do all 7, and when you're all done, save them in a text file or something, just copy paste. Jesse, I have nothing to hide, so there you go. But it's not about did you get the quiz right. It's being able to solve the binary games. That's what's important. The proof that you did it is you copy pasted the answer into that quiz. So the quiz isn't really the work. The work is playing the binary games. Any questions? If there are none, then we can make like bananas and leave. Oh, I see a question. For the H105, 6 and 7 challenges, you need to get 200 correct in a row without any mistakes. Otherwise, the count resets and you need to get 200 in a row. Is that by design? That is by design. Big like spotting and bounce. Yep. When will this video be available for replay? It should be pretty quick because it's streaming to YouTube right now. So I think once I end the stream, then it's visible.